Today we start by talking about photography, ancient photography. Of course, this is not exactly the focus of our podcast, but you already know that I like to start with something that has nothing in common with the subject of the episode, but that follows my personal and probably weird fantasy. So I want to introduce you the pinhole camera, going back in time. What is it? A pinhole camera is a simple camera without a lens, but with a tiny aperture, the so-called pinhole, effectively a light-proof box with a small hole in one side. Light from a scene passes through the aperture and projects an inverted image on the opposite side of the box, which is known as the camera obscura effect. The size of the images depends on the distance between the object and the pinhole. Is everything clear? I'm sure yes. Since we are talking about pinholes in the ceramic field, there is a very common defect that has to do with the porosity of the ceramic material, and that is called, just by coincidence, pinhole. How weird. This is a problem that can be visible already during the glaze application, but that can often be present even after the firing cycle. Its origins and causes are many, but what are the most important? And what do we need to know to avoid and prevent it? I am Davide Trentini, and this is Apparently Invisible Chemistry in Ceramic. As you already know, after the early phases of the ceramic production process, and I'm talking about the forming and shaping of the ceramic body under the weight of the ceramic press, as well as of all the applications that take place along the glazing line from the end of application to the decoration step by means of digital printing machine. After all these phases, the process involves a final application of grit or glaze, sometimes in significant amounts. Of course, if you do not meet the proper parameters, this final application that occurs just before the firing process can sometimes lead to different kinds of problems that may compromise the ceramic surface, both technically and aesthetically. Among the several defects that may occur after the application, the most frequent is the appearance of almost invisible holes or pinholes that can be localized or spread all over the surface. There are several reasons for this problem, but the most important must be found not only inside the kilns, but also, and above all, in all that stages that come before the firing process, especially along the glazing line. So let's try to point out the core scenarios that are at the root of the problem. The first to consider is the temperature of the ceramic material as it leaves the dryers. And here just a little reminder. Inside the dryers and before entering the glazing line, green tiles are still marked by a residual humidity that can range from 5 to 7%. And that's why they undergo to a thermal cycle so to reduce the humidity to almost zero. And this zero is a value that is very, very important to avoid problems during the final firing process. And now let's go further by adding another element. When tiles leave the dryers, they must have a relatively high temperature. Why? Because the high temperature of the tiles ensures a better development of all those applications that follow along the glazing line by losing, we could say, quite quickly, their water content by evaporation. What does that mean? The evaporation process, promoted by the high temperature of the tile, makes the surface dry and therefore properly ready to receive the subsequent application. And this avoids the presence of excessive water that sometimes, instead of promoting a proper cohesion between the application discharged on the tile surface, could lead to a mix or a blending. And this, obviously, could be a serious problem. That said, we must also add that it is also important to keep just a little of humidity to promote a proper application and cohesion of the different layers, just like a cake. So it's clear that we must be very careful in finding the right balance that is delicate and never constant. But let's move on. What if the temperature of the ceramic body that leaves the dryers is improper or too low? This could cause uneven drying of this final application of glaze or grate before the tiles enter the kilns. And this uneven drying process could lead to critical issues at the interface, that is, we could say the touch point between two application layers, that result in different kinds of defects. And pinholes are for sure one of the most popular. Since we cannot make a detailed list of the wide range of causes and effects, we can simply say, only as an example, that the mix between different phases or layers and the abnormal presence of water in the glaze during the firing process are the most important aspect to check, since they are commonplace. In very short words, the pinholes formation starts from a lack of cohesion between the application layers because of the wrong temperature of the raw tile. And this is it. After this long introduction, let's now introduce the actions that can prevent or even solve the problem. The increase of the ceramic body's temperature could surely help the regulation and the adjustment of the drying process. However, the only use of high temperatures can lead to a too fast and uncontrolled drying process, compromising the right cohesion within the application. For this reason, the most significant and smart action that could be taken is to add the glaze with a proper leveling agent, or more generally with chemicals able to adjust and standardize the drying and drainage time, and so to ensure a good cohesion between the layers. But, and this is the second scenario, pinholes can also appear when the graphic decoration of the tile include patterns that require a huge amount of ink. Why? A significant quantity of ink involves the high presence of high boiling organic matter that does not evaporate inside the kiln during the first stage of the firing process. If the amount of glaze or grate discharged on the ink is significant as well, our problem comes out. What happened? It happens that some of the organic matter of the ink may not reach the burning stage before the melting process of the glaze or grate. The problem is that the combustion of the ink's organic matter keeps going even after the melting process of the glaze, and this means that some of the organic matter is not more able to leave the tiles, forming gas bubbles that remain trapped inside the glaze or inside the grate. The bubbles that rise on the glaze surface that is now vitrified explode, producing holes and pinholes that affect the ceramic surface. That's great. What can we do now? Of course, it is not possible to increase the times of the firing cycle to provide the organic matter with longer time to properly evaporate because of industrial productivity reasons. So, one of the most effective solutions is the use of inks marked by a better combustion of the solvent that in turn is marked by a burning process able to remove most of the flue gas before the melting process of the glaze. And now let's see the third and final scenario. Pinholes can be also promoted by an improper balance between the materials involved in the production process. What does that mean? In our case, we are talking about the relation between engobe, grate and the glaze applied at the end of all processes as a protection covering. These three are usually chosen to provide the glaze with the best conditions in terms of compatibility, uniformity, as well as fusibility during the firing process. The problem usually comes out during the first production of a new product range when the producer defines the combination of materials to use. If the latter show even a small chemical incompatibility, many different issues may arise during application. And in this case, we should go in two different directions. On the one hand, the glaze producers should focus on the specific formulation of the glaze, or of the grate of course, that must be used, because sometimes these two could not meet the production parameters of the ceramic producer, such as, for example, the application technology or the kind of firing cycle. On the other hand, The parameters should be also revised inside the labs by a study of rheology, with which it's possible to choose the right chemicals to promote the best possible application. And even this episode ends here. I thank you for being with us, and I remind you, as usual, that all the podcasts are available not only on the main platform, such as Spotify, Apple, or Google Podcasts, but also on our app, in which you can find other interesting contents, hopefully, and that you can download for free on Apple Store or Google Play. You can find it by typing ZMS Ceramco, CERAMCO.AT, or Apparently Invisible. See you soon.